Okay, let's dive straight into this explainer. We're going on a spatial journey today, literally from the highest, most jagged mountain peaks all the way down to the deepest, darkest oceans. Together, we're going to unpack the natural features that make up the surface of our world. To start with the macro view, our planet's surface? It's not uniform at all. In fact, a massive 71%, nearly 3/4 of the Earth, is covered in liquid water. That leaves just 29% to make up all of our solid landforms. So, here's our game plan. We'll start big with the continents, move up to the high ground, drop down into lowlands and deserts, check out where land meets water, trace some flowing rivers and lakes, and finally plunge into oceans, seas, and straits.
Part 1. The Big Picture. Continents.
Continents are those massive, continuous areas of landmass separated by water bodies. We've got 7 of them. Dropping down by size, we start with the massive expanse of Asia at number 1, straight through to Africa, the Americas, Antarctica, Europe, and finally down to our smallest continent, Australia.
Now, this next part brilliantly illustrates just how dynamic our planet actually is. If we rewind the clock, say about 240 million years ago, all 7 of those continents were actually connected. They formed one giant continuous supercontinent known as Pangaea, all surrounded by a single incredibly massive ocean. It took about 200 million years for Pangaea to slowly break apart. Those land masses essentially shifted and drifted to ultimately form the diverse map of distinct continents and separating water bodies that we recognize today. The surface of these continents has changed so many times over the millennia. And the crazy part is, it's actually still changing right beneath our feet.
Part 2. High ground, mountains, and plateaus.
The big distinction at these high elevations really comes down to shape and scale. Mountains thrust violently upward with these steep, jagged summits, whereas hills offer a much softer, uniformly rounded topography at lower heights. Understanding these formations is absolutely crucial, because these immense structures literally dictate wind patterns and water flow across our entire continents.
And here's a totally fascinating fact for you. Mount Everest, part of the towering Himalayas, isn't just the highest peak in the world right now. Because of the constant, incredible pressure of tectonic plates colliding beneath the surface, Everest is actually still growing every single year. Now, contrast that steep, jagged mountain peak with a plateau. Plateaus are raised elevations too, but they feature these distinctly flat, table-like surfaces, which is exactly why they're often called tablelands. Because of their ancient geologic origins, these formations are typically absolute treasure troves of mineral wealth, historically driving massive mining industries and shaping global trade. Part 3. Lowlands and arid deserts. You know, plains don't just magically appear out of nowhere. They're actually actively formed by the high ground we were just talking about. As rivers flow down from mountains and hills, they bring down this really fine soil called sediment. When that sediment is deposited across large, flat, low-lying areas, boom, it creates plains. Because of this process, plains are incredibly fertile and perfect for growing crops, which is exactly why the vast majority of the world's population lives on them. But of course, lowlands aren't always lush, green, fertile plains. The stark opposite is a desert. We're talking vast, unforgiving expanses of sand or rock, completely starved of rainfall and practically devoid of plant life. As you can imagine, these extremely harsh environments pose immense challenges for human survival and for building infrastructure.
And keep in mind, you shouldn't just picture blazing hot sand dunes when you hear the word desert. While the Sahara in Africa is for sure the world's largest hot desert, regions that are completely covered in thick layers of snow and ice, like Antarctica, are actually classified as cold deserts.
Part 4. Where land meets water.
When solid land extends out into the water, we classify it precisely by its borders. A peninsula, like the southern part of India, extends beyond the mainland and is surrounded by water on exactly 3 sides. An island, on the other hand, is a piece of land completely encircled by water on all sides, no attachment to the mainland whatsoever. The exact boundary area where the land actually touches the sea or ocean is what we call a coast, and coasts are incredibly important zones for us. They often feature those narrow strips of sandy land along the water we know as beaches, and they're home to harbors and ports. Those are vital, safe water areas where boats can be docked and massive ships can load or unload goods for global trade.
Part 5. Flowing rivers and lakes.
Rivers are essentially natural streams of moving water, flowing in channels with distinct banks, but they differ greatly based on where their water actually comes from. Perennial rivers are snow-fed, meaning they hold flowing water throughout the entire year. Seasonal rivers, contrastingly, rely strictly on rainfall. If there's no rain, those rivers will literally dry right up.
Sometimes, though, water doesn't flow out to the ocean. Instead, it pools in a basin. When a water body is completely surrounded by land on all sides, we get a lake, or a pond if it's on the smaller side. Funnily enough, the Caspian Sea is completely surrounded by land too. It's actually just the world's largest lake, simply misnamed as a sea because of its absolutely massive size.
Part 6. Oceans, Seas, and Straits. We divide our planet's giant, salty water expanses into 5 massive oceans: the Pacific, Atlantic, Indian, Arctic, and Southern Oceans. Then we also have seas, which are large water bodies too, but they're smaller than oceans and they are bordered by land. A really critical takeaway here is that the water from both oceans and seas contains a massive amount of salt, making it entirely unfit for drinking.
Finally, think of these next 2 features as total geographical opposites. An isthmus is a narrow strip of land that connects 2 larger land masses, separating 2 bodies of water. A strait is the exact reverse, a narrow channel of water connecting 2 large water bodies, separating the land. What's absolutely amazing is that human activity can actually break an isthmus to create an artificial strait. That is exactly what we did with the Suez Canal back in 1869, physically cutting through land to connect the Mediterranean Sea with the Red Sea, which permanently transformed global maritime trade.
So let's wrap this up. From the ancient, massive shifting of Pangaea to the modern flow of our perennial rivers, we've successfully mapped out the incredible vocabulary of Earth's surface. We've seen how everything connects, all the way from those high, jagged plateaus down to the deep, salty oceans. Which leaves us with one final, pretty fascinating question to think about. Considering just how much our Earth has changed since the days of Pangaea, how do you think these incredible landforms and water bodies will shift, grow, and transform over the next 200 million years?